The next talk is by Jaideep, who's a co-founder at 1-to-N Consulting. They help solve problems of scale for all of their customers. He's going to talk today about FMEA of distributed systems. And with that, it's over to Jaideep.
Okay, thank you, Nishan. Anyway, this is the slide. Fine, let's move ahead. What does this look like? Anybody? थोड़ा जोर से, louder, please. A fan, right? Looks like it's a fan. How much is the cost of this? Can anybody guess about it? Like, wild guess. Anyone? 800? $800? $800? Rupees, okay, oh fine, yeah. So, okay, fine, so it's 800 rupees, great. Maybe you should ask one guy who says that the cost of this fan was $100,000 for him. Now why? Who was he? Let me tell you that. So there was this guy who has, who's the head of this department where they have this processing industry, and there's a $1 million machine which has this fan. Now when the fan is there, the machine, one fine day, it just stopped working. And why it actually stopped working? Because there was this fan which gone down. So because of the heat, that fan went down, and this your 800 rupees, that's approximately like near about $10. A $10 fan could actually just take on a complete $1 million machine. And what was the impact on this? Well, the impact, I'm saying this $100,000 is not just the dollar value. Well, it is part of it, yes, I understand, but also multiple things. That's a reputation, there's a customer dissatisfaction, and, like the trust that it has been broken because there was a downtime because of this fan, right? So what do you want to expect about this? How do you go about this? What do you need to do? Is something that we want to talk about. It's called an FMEA, which is called as failure mode effective and analysis. And what really we want to expect is about the what part. We'll be taking from a very first principle point of view, like the what part and the why part and how, and what are the key takeaways and why should you even be bothered about it. So what is FMEA is failure mode and effect analysis, which basically says that you reach some point of a failure by doing up a sequence and a series of injection of the failure into your system, and where you find out and start identifying a single point of failures into it. And this is what FMEA is. It has been used in previous industries, a lot of other industries, like as in 1950s, take an aeronautical engineering, take automation, take civil engineering, and it actually started coming to the software systems later. Systems fail. Oh, that's what just happened right now. Yeah, systems fail. So, okay, so systems fail, have failed, and will fail. Like, there is this, I have come across the people who have said that, oh yeah, it's running in cloud, it will be working fine. But you need to have a notion about it, that you need to have this notion, first of all, before even approaching it, that convince yourself that systems do fail. You need to identify. Like, if you're unaware about it and that, yeah, it just works, it's something then, wrong. You have to, first of all, change the whole ideology and the mental model of yours before you even start doing it. So systems fail. In a data center, what all can go wrong? A hard disk can crash. A RAM can go kaput. There can be heated up. The power grid can be just taken down because, yeah, there was a power failure. Then, some, like, a poor chap just, unplugged the right cable to the wrong one, and, you have a network partition there. So it just stopped working. These are all your hardware failures. When it comes to your software failures, well, a kernel process, there's a kernel that is running, the process can die. There is a bug that is introduced, and that DNA is actually being carried over to most of the kernels. And, one day somebody identifies it. Well, yes, it does happen. So probably that last slide just helps me perform in FMEA, because while this the system, there was an interruption. What was the other alternative? I'm pretty sure that these guys must have done their FMEAs, that they identify what they need to do. And, why do you even care about it? There are multiple reasons. You need to, so I think this is from my past experience at working as an SRE, is while you are, at the middle of the night at 3 a.m., if your pager duty or your page buzzes up, you're the first guy who has to wake up. And while at 3 a.m., nobody wants to fix a bug, you want to go to sleep. But in the situation that you're able to fix the system and able to go on to your sleep, you need to have the familiarity with the system that where all it can break. You need to identify that. You need to start understanding it. And you just can't say that, okay, fine, I mean, it's a distributed system, people have used it, sure. Everybody has their own set of environment, and you need to get familiarized with your environment where it can actually go wrong, right? So, you need to identify your known knowns and your known unknowns before you even proceed. You take up a judicious call, like, fine, okay, I know that this can go down, but I'm aware about it. That awareness is also important, and that how do you approach about it? Let's talk about that. So we will be talking first with the overall systems, and then we will be talking about at the particular components level that how we did that. Oh, sorry. So this is a very familiar, very new, microservices architecture, where there's an e-commerce platform where you have this transaction coordinator. I think most of you guys must have attended Rajiv's talk where he talked about two-phase commits. There's this wallet, there is an order, and both of them service have their own databases, a DB1 and a DB2. It's a mix of a synchronous and asynchronous architecture where you have this queue. Then there is a feature of search, then there is a catalog. There is probably some kind of a full text index, which is your movie or Elasticsearch. And there is this service which actually just updates your cache when as it is required. So this is, maybe it looks too much to consume right now, but it's a very simplistic, microservices deployment that we have these days. I assume that all of us must be having this integration test, like you run up end-to-end test suite and it looks fine, yeah, all good, life is good, we are happy about it. Sure, yay, team is happy that this works. But wait, does this really, really work? Is the 200 okay is what I am actually just looking for? Maybe not. There's something behind that we need to check. First is like, why did it even work? How can this thing work? What was it? Like, there was no bug into it? Like, seriously? Or what am I doing wrong? What I'm missing here? You should have probably, did you have your deep checks to your stateful services? Did you actually have them, where it checks the health of the system, not just doing up a /ping and you are fine and returning a that works. It should be like, really actually they're making up a deep check to your database, doing up some kind of a dummy insert or doing some kind of a read and then coming back. And then think like, okay, what would this integration test of mine would have worked really well if there was some kind of a downfail, or like if there was some kind of failure onto the system. So let's just, the architecture diagram that we had, let's just take some cases around it. So there is this catalog, which is the catalog feature. This is the most important thing whilst a user for your business and user comes to your product, and it is the first thing that it starts browsing. Very common thing. So most probably, you're reading, the source of the truth for this system is actually this DB3, where, but there is this update invalidate system which actually just pushes to your Elasticsearch and probably to your cache, and it just updates it. Now, let's say, what happens when the cache goes down? What is the other alternative? Anyone? What is the other alternative? Sure, perfect. Makes sense. Let's like have another path which actually just talks to the database, right? Yes, it works. What's the another? Now, there's another problem with this. What's the another problem? What's the other problem? All right. So the other problem is that there's now too many users who are coming to your system and actually just reading from this database, because it is doing up a lot of, quite read heavy, there is a problem and a chance that your system might choke up. Then what can you do? You can probably just have a replica of it, right? So you can have a sync up, like a DB3 dash, which is just a replica behind a load balancer, where your, like the catalog microservices just speaks to that load balancer, and actually, in between that load balancer just gives you that system and serves your request, right? So that is, so you need to actually start identifying where it actually could have failed. We probably just took your case down and then start identifying what happened, right? Let's take another case. This is a transaction coordinator. Maybe if you want to complete that order, you have this two-phase commit thing. There is this wallet service, there is this order service, and there is this DB1 and DB2. Let's say while you are, while a transaction is happening, suddenly your DB2 actually just goes for a toss. It just goes down. And now what happens? What do you need to do? Somebody have to probably just jump in and manually fix it. Well, sure. But now, since you started it and now you know that what will I actually do when this piece of component actually goes down? What can you think about it? We attended the talk, so what can you think? What can be done about this? Anyone? Right. So what you can do is probably, how about a service which actually, since anyway you are using up an asynchronous queue, maybe just put those requests to the queue and actually just replay a service which actually maintains the consistency of the system later. Now, to your transaction coordinator, that serves well, like fine, okay, fine. You need to handle it at your order service, that if for some reason I'm not connected to my database, maybe I should just push it to the queue which I'm anyway connected to, right? Now, yeah, so basically you start identifying these kind of problems into your systems. Let's take another case. There is this case 3. Let's say your transaction coordinator actually just goes down. Now what happens? So most probably you will not be able to do your, actually money-making transactions, which is helping you run the business, because if this service is down, it's a very critical and a crucial component, right? But do you want to just leave it there and just say, go home? No, maybe not. What do you really want to think? That, okay, even if there is this problem down, you are able to actually understand that at least your product is usable. Maybe I can just, from this auth service, you are able to connect to your wallet service and at least just check my balance. Or maybe just do some update there and there, right? Maybe I should be able to, my product should be able to just connect to the order service and at least find out what are my previous orders in the past. So don't leave your user, into the middle of nowhere. I had a recent experience. There was this famous policy market thing where I just purchased for my family, and after I filled it up everything, suddenly it just ended up, it didn't save my state anywhere, and I had to just go and refill it again. It was really annoying, really, really annoying. Because these things you tend to do it in the morning, and this is the one thing that, just turns it off for you when that happens. So probably if it would have been a nicer error page, I would have been like, fine, okay, it's something somewhere in the cart, probably they would maybe just try it at their end, and, helping basically just get out of this. So this looks fine. There are many services that are working fine. This was a very simple small set. But how do you even approach when the scale of the services just increases? Let's say if you are like 100 microservices, you won't be able to check like, do this, identify what's your failure point. Well, you can say that I can write an automation script. Sure, you can write your code. But even identifying what do you have to write your combination, that one is a major challenge. It will take a lot of time, and how do you identify that? So probably just look at this previous architecture diagram that we had. Now, if we had that, if you see that there is a cache, if we go back, probably if you just look at this alternative approach, where LDFI says that you start taking from your good point, like, okay, this is my failure point, let's start, everything is working fine, let's start from there and let's start failing this system. And then you start backtracking it where it will actually fail, right? Now, so LDFI is linear different failure injection, and I want to actually just take back you to one of the slides here, while our cache was down, what was the alternative path that guys actually approached? So if in case this catalog service was actually, could not connect to your cache, it would probably took up an alternative path and actually reach the DB3, right? So you would always start failing. So you start failing your cache system and then start saying that if it is able to restart, it's able to reconnect again and actually serve the purpose that it should be, right? Now, if you see that there was this alternative path that actually helped complete the request, yeah, right. So here, so there was this alternative path that actually helped complete the request and able to serve the request fine. Yeah. So implement an LDFI and actually even identify that mental model in your head, you'll have to probably have something that is already there into the system. You have a distributed tracing, because based on that, you can start identifying your call graph, like where it is, what are your successful outcomes, where it can be actually failing it, and identifying the cascading failures onto it. So you start now injecting faults to your graph at a very specific areas, which you start identifying are really critical, and then start backtracking it where it can be actually fixed to a system. So this was using this technique and approach, we were able to, I'm taking up a subset and a snapshot of certain microservices that we had. It was the overall system was like quite huge, but we just took taking up the snapshot for the sake of understanding that how we were able to do that. So if you see this API service, that API service, the developers actually wrote the code, they pushed it was working fine. And while as an SRE we were trying to test it at what are their failure points before even deploying it to the production, we identified that the client library that was using was not able to reconnect the moment the DB used to restart. And the service either used to just go down or it used to just did not make any connections. So it was failing then and there. So we identified the problem, asked our developers, like, please, maybe you should just fix this thing because this is not working while you are trying to connect. So other thing to fix was that actually the queue model, the queue was, we were running up distributed queues, and the queue accidentally, the configuration of the system was with just, the replication factor was just 1. And while there was some asynchronous, some model engine that was a machine learning model engine that was working in the background, was not able to connect to the queue, and it started failing because that node in which the queue was served was actually down. So this is the overall system about how you do for a larger scheme of things. Let's say that you want to, tomorrow there is there is some kind of a use case where you actually have to deploy some kind of a distributed system. Now, how do you even approach about it and how do you even go about it? And that's the next thing that I want to be talking about. So FMEA for your components part. So first, before I actually go how we did it, I would just want to explain the use case. How many actually understands the DR site? Okay, fine. So a DR site is basically a disaster recovery site where in case of your infrastructure actually just goes down, you have an ability to back up some kind of your data as well as your service. Like data is a primary concern. And this is for most of the fintech companies which actually are really careful at what is actually deployed. They want to be, even because there's a lot of legal licensing and other certification that needs to be taken care. And to achieve that, you need to set up some kind of a DR site where you're able to prove that in case your cloud provider goes down, I'm still good and I'm still happy, I still have my data consistent. So this will, I'll just explain quickly, and make you understand like what exactly it is. This was a cloud with two AZs, and this was a data center with 2 racks. And we were using, we wanted to use, for some reason, actually, a distributed storage layer for stateful containers. Now, it's called Portworx. I don't know if any of the guys are from there. They have an office in Pune, by the way. I'm not. So, and then there was and that system was actually dependent on a KVDB that's called a console. I think you must have heard about it. And what we had to do was that there's two machines in the cloud, two machines in the data center, which were actually syncing. And what we really opted, and we wanted, a consistency was a major concern, so we opted for a strong consistency. The system actually gives you the ability to have a quorum-based consistency, which will have given us the availability, but we wanted to actually have a strong consistency for the system because of the criticality of the system. Now, so these systems are syncing, so how did we actually approach, started doing an FMEA for this thing? What we did was, we started our DB container on a machine and actually rebooted the machine. And then we wanted to check. So what we identified that the orchestrator, in our case it was a Nomad, and it actually detected automatically that the node was down, and it needs to respin it up somewhere else on the other side of the machine, and it did that. So the total data loss was nothing. The app downtime was less than 2 minutes, because where it started even to identify the time it actually took to identify the node has been down, and meanwhile the volumes got detached and actually got attached to the other side of the system. This was the observation timeout. So the case 2 is that we started a DB container on a machine and actually just rebooted the other machine. Does it affect the cluster? Well, it was a very happy path and a happy case, and there was no side effect and no observation on the timeout as well as on the the data loss. We started. The third case was where we actually brought up the container and actually killed up the portworx process. And then now we wanted to observe how does it behave in case the process itself is killed. How will my contain the stateless service, which is dependent on this kind of stateful service, which is making the connection, how does that behave in that system? So, well, the recovery was automatic. We observed that we don't have to do up any kind of a manual intervention. We just observed and let the system fail. And we observed that because of the database, which was actually, did up some kind of a write to the file system, there was, and while it was still waiting for that acknowledgement that it to come back, it was not there. So it was not actually, flushed to the disk. And it just kept on waiting, and eventually it just crashed. So the observation that if we are able to, bring down the timeout of the of our database into our configuration, maybe this should be helpful. And that is how we actually approached. So we started a DB container on the machine and actually killed the console on that particular node. Now, while we killed that, the whole portworx node of ours was actually dependent on the KVDB. So if it was dependent on it and that process itself goes down, that node will be unusable anymore. So how do you actually process about that? So we thought that maybe if this guy, the portworx node, can able to talk to its other console pair, that should be helpful and it will be still safe. So we wrote like some kind of an our automation code where in case of the one node goes down of our console or the KVDB, you are still able to, it is still reachable to that particular machine. We did up a network, the fifth case was that we did up a network partition between our cloud and our DR side. And then we wanted to observe that how does it actually behave. And what we observed was that, yes, we wanted up a very strong consistency. That is what we wanted. And this is what we traded off with availability. And we were fine that even if the system goes down and if the writes are failing, that's okay. We want a very good, a consistent system to be actually running. So, yeah, that was the preferred model that we had to do. So, now I'll say that what are the key takeaways to it? Well, build your mental model first in your head that you should be convinced about this and that you have to do this. And how to do this? We talked about LDFIs. Well, you can think, which has been the stepping stone for chaos engineering. Like, this is a buzzword these days that we want to do chaos engineering, but how do you even set it up? Because first approach is to actually do it manually. You have to do it manually, write some bash, even a bash will be fine. But now when you know that what you have to do, you can use any of the tools in the market or build your own, because you now know the input, because every software system or any function in life needs some kind of an input to even process something, right? So that input has to be your engineering team's mental model and the thought process, where everybody is on the same page how to do that. If possible, try any system that you actually deploy, maybe just try what was their kind of a chaos scenario, what was their FMEAs that they have done, and they start evaluating their outcomes. And also very important is that their use cases may vary for enough. You need to have enough trust on your system before you go ahead and actually deploy them. As I said, that you will the first one and in the first line of fire when the systems will break, and you will have to fix that. Yep, that is me. Thank you. Any questions, please?